In this tutorial mini-series, I'm going to teach you how to make the particle systems, shaders, and scripts for a fireball projectile that hits a campfire and lights it up. By the end of this, hopefully you'll understand things well enough so that you can use this knowledge for a variety of other effects. I'll start off with the campfire, and more specifically, I'm going to focus on these flames, which will give you almost all the knowledge you need to create the rest of the effect. And then I'll quickly go over the rest of the effect just to make sure I've covered everything. I'm using Unity 6 with URP, but you can follow along with any version of Unity from the past few years because the functionalities I'm using will be pretty much the same. And you can follow along using HDRP too, but I haven't tried the shader graph of the built-in render pipeline, which apparently exists, but I imagine you could follow along with that as well. If you're interested, the campfire logs are free, and one of the fire sounds I'm using are free as well, but the environment and dragon are paid assets from the Unity asset store. By the way, they're just random assets I found that I liked. Alright, so I have a particle system which I called PS_campfire. PS is short for particle system, and it's also the sound that smoke makes. Psst. Write that down. PS Campfire doesn't do anything. All its modules are turned off, such as the emission and the renderer. It's just there to be the parent of the other particle systems, so that if you click on it, you can press play in the scene view and all the children particle systems will play. And if you call the play method via script, all the children particle systems will play as well. Inside PS_campfire, I have an audio source for the constant sound of the campfire when it's lit, and below it I have a point light to make it seem like the particles are emitting light. I might have left this point light on in some parts of the video when it shouldn't be, so if the campfire is glowing unexplainably, that's why. Then I have PS_fire main, which is basically billboards that are always facing the camera while staying perpendicular to the ground, and the material applied to them has a scrolling distortion. But you can see it looks flat from above. One thing I did to fix that is use Fresnel to make the particles fade out when you look at them from above, like this. Then I have another particle system with non-directional flames, and these are just standard view-facing billboards. Alright, so next I have the smoke particles. The two fires and this smoke use different materials, but they all have the same shader. Lastly, I have ember particles. Before you start, it's good to find references. For instance, here is a random fire I found from a YouTube channel called Phobos Planet, and on the right is a fire from Zelda Breath of the Wild. You should try to figure out the things you like about the references and want to incorporate into your effect, and which things you want to change or simplify. And of course, you can always experiment as you're making the fire. So I wanted to have the overall chaotic feel that these fires have, as opposed to having a more calm fire like Animal Crossing. Also, the Zelda fire has a stylized feel, like it's one layer of flames, which is how I usually make fires, like this one, but I wanted to do something different to what I usually do, so I aimed to have a more layered fire, like the real-life reference. I like the way the Zelda smoke dissolves away, but I also wanted my smoke to have a more faded out look. Also, in real life, we can see that there is a hue shift from yellow to where it's hottest to a reddish orange where it's less hot. So these are all things I kept in mind when I was making my fire. Now let's make the main texture of the first particle system. I use Krita, but you can probably use whatever drawing software you like. I'm just going to use the brush tool, then apply Gaussian blur. And if you don't have a drawing tablet, that's fine. I'll do a second demo just using my mouse. I experimented with making a fire differently to what I'm used to, and I found this brush, which I really like. It's called Wet Smear. The edges of this brush have a fiery quality, If you don't have a brush like this, you might be able to just paint it manually or give the layer an effect that mimics this feel, or you can just make a different style of fire. I suggest you experiment a lot. Draw lots of different fires and see which ones end up looking nice when you actually import them into Unity. Definitely don't spend more than maybe 5 to 10 minutes on each design that you're testing out, because it can be hard to tell what will actually look nice in Engine. A texture that looks nice by itself might not give you a nice final result in Unity. So it's best if you quickly do a few different options. Then you can see which ones are bad and which ones can be fixed, and analyze what you think you need to do to fix them. So now I'm duplicating the layer I drew on, and I'm applying Gaussian blur. Clicking this icon lets me blur the horizontal and vertical directions separately. Now I'm unhiding the original layer and turning down its opacity. This is the actual texture that I made before I started the tutorial using the same process. But I also drew another option with a mouse, and I actually think the end result in Unity looks better than the drawing tablet versions. I just had to decrease the size and opacity of the brush manually because you can't press softly to make the brush less opaque or smaller. One thing to keep in mind is that this is about how it'll look in Unity when we're spawning about 5 particles per second, each with a bunch of effects like dissolve and distortion. I quickly tested this version I made with a mouse on ps_firemain, and like I said, I think it might look better. So make sure you export this to somewhere inside the assets folder in your Unity project. I exported mine as a PNG because it's lossless. For this tutorial, you don't really need to worry about most of these settings. Just untick alpha if you're not using transparency, so the file isn't bigger than necessary. If you hover over these options, most of them show you a tooltip, and you can also read more about it if you want. Also, just want to quickly say something about transparency. You don't need to understand exactly what I'm doing now, but if you think you might end up using your image with a default Unity particle shader, like this, which is generally better for performance than custom shaders, then consider exporting your image with a transparent background instead of a black background like this texture. As I'm about to show you, the default particle shaders use the colors in your texture to determine the opacity and the actual color that the particles should display. So your texture fades out in the darker parts, but its color also becomes darker in those parts. For instance, look at how the faded white edges are a darker gray as well. But in our case, we'll make a custom shader that doesn't need the alpha channel. Now, continuing with the fire, I'm going to navigate to the folder I created called Shaders and Materials, and I'll right-click in the project window to create a custom shader. It's a URP unlit shader. Give it whatever name you like. I use the sh prefix for shaders just to keep the files organized. Double-click on it to open it, and then you can double-click on the tab with the shader name to maximize the shader graph window. In the shader graph, you move around by clicking and holding the mouse wheel. Let's right-click and create node and search for the sample texture 2D node. Double-click on it. Click this tiny circle with a dot, which I'm sure has a name, and look for your texture. This is the original texture I made, and it uses alpha, but Unity doesn't display the 4th channel in the preview of nodes, so let's drag a wire from the alpha slot and plug it into the preview node, just so you can see it better while we're in the shader graph. Plug it into the base color block node of the master stack. So now we're using values from the alpha of this texture to determine the base color of our shader. And we can do that because the alpha values, the red channel, they're all just values, They're not like special and can only be used in one particular way. So right click on the main preview and change it to a quad, just so we can see how it'll look when it's a particle system billboard. And let's change our material from being opaque to being transparent. And actually, let's delete this connection and plug it into the alpha block node. This fire texture has values ranging from 1 to 0. The alpha block node processes the values you pass into it by making 1s be fully opaque and lower values are less opaque until you get to 0, which is fully invisible. This here is the default color. We can click on it and set it to red, for example, but let's make it an adjustable value. Also, don't forget to save on the top left so that the changes in this shader will actually show up in the materials that use this shader. To make the color adjustable via the particle system, let me quickly explain the vertex color node by using a new lit shader. Don't follow along to this part. I made a custom shader where the vertex color of the mesh is used to directly determine the base color. Then I made a material from this shader. Here are two meshes using a default Unity material. On the left is a default Unity sphere, and on the right is a sphere I made in Blender, where I painted its vertices like this. Meshes come with vertex color data attached to them in the form of RGBA, red, green, blue, and alpha for transparency. By default, Blender and Unity, and probably most other software in this area, assign vertex colors of a mesh to have RGBA values of 1, 1, 1, 1, making them white and fully opaque. Now let's get these meshes to use the material I made, where the base color is dictated by the vertex color. As we can see, the default Unity sphere has white vertices, and now here is my sphere. Now let's use this sphere and material in a particle system. In the particle system, the default way to change a particle's color is with start color, which simply multiplies with the vertex colors of the mesh. If I pick red, all these colors will be multiplied by red. Pure red has an RGB of 1, 0, 0. Also notice how the white parts of my sphere are exactly the same as the start color, because white has RGB values of 1, 1, 1, and any number times 1 is itself. For example, 0.3 times 1 is 0.3. Back to our fire shader, right-click, create node, and find vertex color node, so we can control the fire color via the particle system. The vertex color node outputs a vector 4 of the RGBA values stored in each vertex of the mesh. A vector 4 is basically a container with numbers, by the way. This split isn't necessary, but if you're a beginner, I think it's good to split the RGBA values and then combine them together, excluding the fourth value, which is the alpha. The base color node expects a vector 3 because color is displayed by combining R, G, and B values. So if you give it a vector 4, it'll just ignore the fourth value. The performance difference is negligible, so it's just a matter of personal preference. But if you're a beginner, I do think these unnecessary split and combine nodes are good for reminding you of these important concepts. Let's save these changes on the top left, then double click on the shader tab to go back to the normal view. Right click on the shader asset and create a material from it. Call it whatever you like. I use the MI prefix, which stands for material instance. Now I'm going to right click in the hierarchy window and create an empty particle system, which will serve as the parent of all the Campfire particle systems. By empty, I just mean I'm going to make all its modules be unticked. Creating this empty parent is useful for many reasons. Like I said before, you can simply click on the parent and press play to see all the children particle systems play. Also, when you're scripting, you can call the play or stop method on the parent's particle system, and it makes the children play or stop playing. Now I'm going to create the main fire particle system. In the renderer module, let's assign it the material that we made by dragging it in from the project window. Before we continue, remember to check if Unity didn't make your particle system rotated by -90 degrees. This can cause problems if, for example, you don't want your particle system rotated by 90 degrees. For instance, you might want particles to move in the positive z-axis of the world, but for some reason they're moving in an unexpected direction. Unity sometimes does that when you add a new object to the scene, for reasons unknown to humankind. Click here on the top right to display the wireframe of the shape module. Inside the shape module, rotate it so the cone points up in the scene. I'm going to turn down the duration of the particle system so it loops every 2 seconds. Then I'll change the lifetime of each particle to be a random number between 0.6 and 0.9 seconds. And change the speed that particles go outwards from the cone shape to be 0.7 and 1.2. These are all just values that I experimented with to get the look I wanted. The start size of each particle will be random between 2.5 and 3.5 units. Let's make it spawn 5.5 particles per second. By the way, here you can see how many particles are spawned and haven't died yet in the selected particle system. Let's decrease the angle of the cone to be 1 degree, so all particles are pretty much just going straight up. Decrease the radius of the cone so the particles spawn closer together. Turn on the color over lifetime module. These colors multiply with the start color, which in this case I just left as the default white. I'm just copy pasting the gradient from the fire I already made previously. You can color pick this video to get something similar, but I wouldn't recommend it. Click above the gradient to add an alpha key to adjust the transparency, and drag it out to delete it. Keep in mind, we haven't set up the shader to actually use these alpha values yet. Click below the gradient to add a color key, and click here to pick a color. The keys on the left are for the start of each particle's lifetime, and the keys on the right are for the end of its lifetime. So in this fire, particles start yellow, then quickly turn orange, then transition to become a saturated red. You probably don't want the actual particles to be this saturated, but since we also lower the alpha, it waters down the saturation, achieving the look I want. In a minute, we're going to edit the fire shader to actually read and use these alpha values for the opacity. Like I said, I don't recommend you copy these colors exactly, because what looks good in your situation will depend on the lighting and post-processing and the environment in your scene. And it'll depend on your intention and your personal preference. Also, the fire shader is barely done, so these colors will give a very different result later on. The particles will actually look nice, so maybe don't spend more than a minute on these colors right now. The main thing you probably should follow is making it fade in and out so the particles don't spawn and die abruptly. So let's edit our shader to use these alpha values. We want to keep the alpha of our fire texture influencing the transparency, but we also want the alpha of the vertex color to influence it. In this case, a simple multiplication of the texture's alpha with the vertex's alpha will achieve the result I want. I'll explain the swizzle node in just a second, but it's very similar to the split and combine that we did before. If you're confused about why this alpha multiplication works, start by looking at 3 points in the fire texture and estimate what their alpha values are. Let's consider this dark gray value of 0.4 alpha. When the vertex color's alpha is 100% opaque, meaning its value is 1, it will multiply with the 0.4 to give 0.4. So that point in the particle will be 40% opaque. But when the vertex color alpha is 50% opaque, meaning its value is 0.5, it will multiply with the 0.4 to give 0.2. So that point in the particle will be 20% opaque. Now look at 2 other points in the texture, such as these, and have a go at doing this multiplication yourself. Now for the swizzle node. I tend to use it more than the split and combine nodes. The swizzle node expects the letters RGBA or XYZW in any permutation. The letters are based on the common inputs that you would plug into this node. Imagine you plug in a vector 4 like we have. R or X simply means first value, G or Y means second value, and so on. For this explanation, I'm assuming that you already know that an image is made up of points called pixels, and each pixel has the colors red, green, and blue combined in different ratios to produce different colors. This is similar to how paints combine to produce different colors. Anyway, in our case, we want the first 3 values of the vertex color node, which are red, green, then blue, in that order. So I wrote RGB in the swizzle node, but I could have written XYZ to get the same result. Now let's save and see that our fire is fading in and out instead of abruptly appearing and disappearing in full opacity like it was before. Now I'm going to make use of the bloom that I already set up in the scene, so that the RGB of the shader can go beyond values of 1. I'm just going to make some room here. We're going to multiply the RGB before plugging it into the fragment stack. I'm going to create a property of type float. A float is basically just a number, and I'm going to call it bloom multiplier. I drag it in and multiply it with the output of the swizzle node. Save the shader graph, and now we can change the values of the bloom multiplier property in the material instance. I'm going to set it to 2. Again, this value will depend on your situation, including the bloom settings that you have for your scene. That's it for this video. In the next video, I'm going to talk about UVs and how to create a distortion effect like this. One last thing to always keep in mind that's very important when making any VFX, which everyone should know, is